Okay, we're going to do number 12 in section 2.1. And it says RT is t to the t, and S of t is arc cosine t. That's on the calculator, that's cosine inverse of t. For which you have, they're telling you that this is the derivative of r of t, and this is the derivative of f of t. It says do not be concerned with where they came from. In the future, we might figure out where they came from, but for right now, they're just telling you the derivatives. And if w is this, determine w prime. Well then, w prime is the derivative of this, which is all of that. So it's w prime of t is going to be t to the t, parenthesis, ln t plus 1. And that is the derivative of that minus 2, a constant times the derivative just stays there, times the derivative of this, which they told us was this, which is minus, which changes that to plus, and 1 over the square root of 1 minus t squared. So there's w prime of t. Now, if we have to find the equation of the tangent line, we're going to have to figure out what this is, what the slope is at 1/2 to be able to do that. So pull out the calculator, and I'm going to type that equation in. So that's x to the x, parenthesis ln x plus 1, close parenthesis. That's t to the t ln of t plus 1, plus 2, and that's all divided by the square root of 1 minus t squared. Only I'm using x's for it, the t. And that's the derivative. And we need to find out what this is at 1/2. And it says this with 1/2 plugged in is 2.5264. So we have the equation of the tangent line at 1/2 is, and this I guess is in t, so it's going to be 2.5264. That's w prime of 1/2. The slope times t minus where we're doing this at, 1/2, plus the y value. So now I got to put 1/2 into the original function, which was 3t squared, 3tx to the x, t to the t, minus 2 arc cosine, second cosine of t, x. And back to my table, 0.5 into that is 0.0269. Though that is the equation of the tangent line. And if v of t is almost the same, it doesn't have the 3 and it doesn't have the minus 2, is v of t increasing or decreasing at 1/2? So now we got to do a whole nother one and find out what happens at 1/2. So we really don't need to know what it is. We need to know what the slope is. So the derivative of this is t to the t, parentheses, ln t plus 1, minus 1 over 1 minus t squared. That's the derivative of this. So if I go back to my original function here, see that? Let's move this over here so you can see this. So we have x to the x, ln x plus 1. That's all of this. Ooh, boop, 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 boop. Oh, I messed up on this last one. This should have been 3 times that plus 2 times. I missed a 3. So second insert before I change anything, 3. That should have been the derivative here. There should have been a 3 on that. So when we put in a half on it now, the slope is 2.9603. 9603. And that's, so we need that in this. There should have been a 3 there. I got the 2 from minus 2, and I should have had the 3. Okay, so now we're going to go back here and do this one, which doesn't have the 3, and it doesn't have the minus 2, so this is minus 1 over that. Oop, that's not times minus 1, but subtract minus 1 over that. And so that's the derivative. We're not looking at this function anymore, so I don't need to worry about that. But go to y equals, and at a half, the slope is negative 9.3. This is v prime of t. And if I plug in a half into this, I get negative 0.938. You can see, in case I didn't show it there, there's the derivative. And plugging in a half, I get negative 9.38. Nope, negative 0.938, which means it's decreasing. Yep. I struggled my way through that one. Made a few errors along the way, sorry. Okay, and now let's do 2.1, number 13. If we have a of x, we're trying to find out what the derivative of a to x is. And we already know that the derivative as a function of x of some constant, like 2 or 3 or 5 or e or whatever, a to the x is ln a times a to the x. Now they're going to try to help you see that. So the limit definition says of a to the x, if f of x equals a to the x, the limit definition, the h one says a to the x plus h minus a to the x over h. That's f prime of x. And if you got x, a base with added powers, that changes to the limit as h approaches 0 of a to the x times a to the h minus a to the x over h, which changes to, see, we can factor out an a to the x. So we get limit as h approaches 0, of a to the x times a to the h minus 1 over h. the a to the x is not affected by the h. There's no h in it, so we can, and it's times this, so we can pull it out. So we get a to the x limit as of a to the h minus 1 over h as h approaches 0, which is what they wanted us to get. Now, we're supposed to use technology to figure out what this is, check it with 2 and 3 to estimate those values. So go to our calculator and we type in A, and we could do it with different letters of A. I'll put in the, they said to do it with a 2, so I'll put 2. Let's see, clear, let's make it a fraction. 2 to the x minus 1 in the numerator over, oh, I didn't do 2 to the x. 2 to the x minus 1 over x. And we're letting x go close to 0, so we're going to go to second table and go point and negative point. And it looks like we're getting this at 2 is 0.6932-ish. And if I change it to a 3 instead of a 2 and go to the table, it's now coming out to be 1.0986 or 7. And it would be nice if this limit came out to be 1. And that would happen if, and they're supposed to look for something between 2 and 3. So 3 was more than 1, 2 was less than 1. It was closer to 1 at the 3. So I'm going to pick a number closer to 3. And since I'm kind of know what's headed, what this is headed for, I'm going to go here and make it 2.7. And then we go here, and it's a little bit too low, so I'm going to go to the equation and make it 2.71, and now I'm still not there. Go to my y equals, and my phone's ringing, but we're going to ignore that here. Put an 8 there. Quiet phone. And we're going to put 2.71828 in there, and I'm going to go to the table, and it says, you're really close to 1. And the number I'm putting in there, let's go to the y equals again, is, erased too much, is e to the, and that's to the x. And now second table, and it says it's 1. E is 2.7181182. Let's go to the home screen. Clear. E is 2.718281828459045. So this A would have to be E, and it comes out to be 1. And then they say, take a look at this and this. After you look at the ln of 2, ln of 2, of course, is 0.693147, so it was close to what we got there. And ln of 3 is close to what we got there. And so therefore, we've kind of shown that the derivative of a to the x, this is ln of a. And what's particularly important about this one is its slope is itself. F prime of this function is itself. And that has a lot of importance in growth factors and that sort of thing. So the derivative of this is 2 to the x ln 2. And the derivative of this is 3 to the x times ln 3. And this is what we did on this one is kind of leading us to that result. All right.